right now, at this exact moment, something you built is dying, and you can't reach it. You can't fix it. And you can't even get an answer from it in less than nearly 2 full days, because it is so far away that even light itself struggles to keep the conversation alive. I'm talking about a machine no bigger than a small car, launched in 1977, now more than 25 billion kilometers from Earth, moving through a darkness so complete that the sun, the very thing that defines our existence, has shrunk to nothing more than a bright star in its sky, indistinguishable from countless others. And yet, despite all of that distance, all of that silence, it is still speaking to us. And more importantly, it is slowly going quiet, not in a dramatic way, not with an explosion or a final burst of data, but in the quietest way imaginable. The kind of ending you might not even notice unless you are paying very close attention. Because Voyager 1 is not failing all at once. It is fading, one system at a time, one instrument after another, like a house where the power is being cut room by room until eventually you are left sitting in the dark, waiting for the last light to disappear. And the unsettling part is that this isn't something that might happen someday. It is happening now. To understand why, you have to let go of the intuition you normally use for machines, because nothing about this situation is normal. There are no solar panels out there soaking up sunlight, because at that distance the sun is effectively irrelevant. Its energy diluted to almost nothing. And so Voyager survives on something far more finite, far more unforgiving. A set of small nuclear generators powered by plutonium-238, quietly decaying, steadily losing power year after year. Not suddenly, not violently, but with the kind of slow, relentless decline that you cannot stop and cannot reverse. And every single watt it loses forces a decision back on Earth. Something has to be turned off. Something has to be sacrificed. And that is exactly what has been happening for decades, although most people never noticed, because from a distance it all feels the same. Voyager is still out there, still working, still sending data, but the truth is much less stable than that comforting picture, because one by one the systems that once defined the mission have been shut down. Cameras that captured one of the most haunting images humanity has ever seen are now permanently silent. Software has been erased. Hardware left dormant. Entire capabilities simply gone. Not because we wanted them gone, but because there is no longer enough energy to keep them alive. And the list of what remains grows shorter. E. Now here's the part I really want you to focus on, because this is where the situation stops being impressive and starts becoming fragile. It's not just the scientific instruments that are disappearing. It's the basic functions that keep the spacecraft alive at all, including the heaters that prevent its fuel from freezing in the cold of interstellar space. And if that fuel freezes, Voyager can no longer adjust its orientation, which means it can no longer point its antenna back toward Earth. And if that happens, the signal doesn't degrade. It doesn't weaken gradually. It vanishes permanently with no way to recover it. Because at 25 billion kilometers, there is no repair mission, no second chance, no way to reach out and fix what has gone wrong. Engineers believe they can stretch its remaining power a little longer, maybe into the 2030s. Maybe keep a minimal signal alive for a few more years beyond that. But those are optimistic estimates. And the reality is that after nearly 50 years in the most hostile environment imaginable, Voyager 1 is operating on borrowed time, where a single unexpected failure could end everything overnight. And when it finally does go silent, it won't feel like a dramatic conclusion. It will feel like something slipping away so quietly that most people won't even realize the moment it happens. And that leads to a question that is much more interesting than the numbers, much more unsettling than the engineering. Because the real question isn't just how far Voyager 1 has gone. It's what it means that something we built can travel this far, survive this long, and then, inevitably, continue on without us. Long after the last signal has faded and there is no one left listening on the other side, if you strip away all the romance, all the distance, all the awe that comes with something traveling billions of kilometers from Earth, what you are left with is something much more uncomfortable to look at. Because Voyager 1 is no longer a mission in the usual sense. It is a system under constraint, a machine being forced to make choices about what parts of itself are allowed to keep existing and what parts have to be let go. Not because of failure in the dramatic sense, but because there is simply not enough energy left to sustain everything it once was. You might expect that somewhere on that spacecraft there are solar panels quietly doing their job, gathering whatever light remains from the sun. But that idea only works close to home, because out where Voyager is now, sunlight has thinned into something almost meaningless, so weak that it might as well not exist at all. And that means the spacecraft has been surviving from the very beginning on something far more finite and far more unforgiving, a set of radioisotope thermoelectric generators, devices that do not recharge, do not adapt, and do not recover. They simply decay. Inside those generators is plutonium-238. And what keeps Voyager alive is not a reaction you can control, but a process you cannot stop. The steady, irreversible decay of radioactive material releasing heat, and that heat being converted into electricity quietly, continuously, year after year. And when Voyager launched in 1977, that process gave it about 470 watts of power, which is barely enough to run a few light bulbs in your house. And yet somehow that small, carefully rationed amount of energy had to sustain everything. The computers that think, the transmitters that speak, the heaters that prevent critical systems from freezing, and all the scientific instruments that justified the mission in the first place. But here is where the situation becomes unavoidable, because plutonium-238 has a half-life of about 7 years, which means the energy output is not stable. It is declining, slowly but relentlessly, and every single year Voyager loses a few watts of power, not enough to notice in a moment, but enough that over decades it becomes the defining factor of everything the spacecraft can and cannot do. And unlike problems you can solve with better engineering or clever software, this is not a problem you fix. This is a limit you live inside. So what do you do when a machine you cannot reach begins to run out of energy? When every function it performs is competing for a shrinking pool of power, and nothing new can be added, nothing can be repaired, nothing can be replaced, you start making decisions, not about how to improve the mission, but about how to prolong what little remains of it. And those decisions are not abstract. They are specific and irreversible, because every time engineers on Earth choose to turn something off, it is not going to come back. This is where Voyager stops being just a spacecraft and starts to feel more like a house where the electricity is failing. Not all at once, but piece by piece, room by room. And at first you shut down the things you can live without, instruments that are no longer essential, systems that have already done their job. But as the years pass and the available power continues to drop, the choices become harder. Because eventually you are no longer deciding what is unnecessary. You are deciding what is indispensable. And even those things begin to exceed what the spacecraft can support. And the truth is, this has already been happening for a long time. Although from a distance it doesn't look like it. Because Voyager is still there, still transmitting, still alive, in the simplest sense of the word. But underneath that surface, the spacecraft has been shrinking, not physically, but functionally, losing capabilities, shedding complexity, becoming a simpler and more fragile version of what it once was. And every watt that disappears tightens the constraint further, forcing another decision, another shutdown, another quiet loss. What makes this so different from any situation we deal with on Earth is that there is no intervention coming, no repair crew, no upgrade, no second system waiting to take over. Because at 25 billion kilometers, Voyager exists in a kind of isolation that is absolute. And the engineers who manage it are not maintaining a machine in the usual sense. They are managing its decline, carefully, deliberately, trying to extend its life by deciding, one system at a time, what can be sacrificed so that something else can continue just a little longer. And that is the real state of Voyager 1 right now. Not a fully functioning explorer pushing outward into the unknown, but a delicate balance of diminishing energy, where survival depends on subtraction, where continuing the mission means letting parts of it disappear, and where every choice being made on Earth is, in a very real sense, a decision about how this machine will slowly, inevitably, run out of ways to keep itself alive. Now, before you let yourself believe that Voyager 1 is only a story about decline, about systems shutting down and power slowly draining away, I want you to shift your perspective for a moment. Because what you are watching fade today is something that has already done more than almost any machine humanity has ever built. And if you don't understand that part, then the ending you are witnessing won't carry the weight it deserves. Go back to the beginning. Not in numbers, not in dates, but in intention. Because Voyager was never meant to last this long. It was designed for a mission measured in years, not decades. Built to take advantage of a rare alignment of the outer planets that only happens once every 176 years. A gravitational opportunity that would allow a spacecraft to move from one giant world to the next without needing enormous amounts of fuel. And what you have to understand is that this was not just clever engineering. It was a kind of precision timing on a cosmic scale, where if you missed the window, you didn't get another chance in your lifetime. When Voyager 1 reached Jupiter in 1979, it didn't just fly by and take pictures. It changed what we thought a moon could be, because before that moment, moons were expected to be quiet, cold, geologically dead. But as the data came in, something didn't match that expectation. And then the images confirmed it. Towering plumes erupting from the surface of Io, active volcanoes driven not by internal heat alone, but by the immense gravitational forces exerted by Jupiter itself, stretching and compressing the moon in a process we now call tidal heating. And just like that, an entire category of worlds went from being considered static to being dynamically alive. Then came Saturn in 1980. And once again, what Voyager revealed was not a simple confirmation of what we already believed, but a level of detail that forced us to rethink the system, because Saturn's rings, which from Earth appear smooth and uniform, turned out to be incredibly complex, structured, divided into countless bands and gaps shaped by gravitational interactions with nearby moons. And beyond the rings was Titan, a world wrapped in a thick, hazy atmosphere that concealed its surface completely, hinting at a chemistry rich enough to resemble, in some distant way, the early conditions of Earth. And even though Voyager could not see through that haze, it showed us enough to know that this was a place worth returning to decades later, with entirely new missions. But here's where the story takes a turn that most people don't fully appreciate. Because after Saturn, Voyager 1 did not continue from planet to planet like its twin, Voyager 2. Instead, it was deliberately sent upward, out of the plane of the solar system, placed on a trajectory that would never bring it back toward the familiar worlds. And that decision transformed it from a planetary explorer into something else entirely, something far more ambitious, a probe whose destination was no longer a planet, but the boundary of the sun's influence itself. And for the next 3 decades, it just kept going, past distances that had once defined the edge of our understanding, beyond the orbit of Pluto, beyond the Kuiper Belt, into regions of space that had never been directly measured by any instrument, moving through a domain where the solar wind, that continuous stream of charged particles flowing outward from the sun, begins to weaken, slow, and interact with the interstellar medium beyond. And what Voyager was doing during that time was not dramatic in the cinematic sense. There were no close flybys, no stunning images. But in terms of physics, it was moving through gradients, through transitions, through boundaries that had only ever existed in theory. And then, in August of 2012, something happened that had never happened before in the history of our species. Voyager 1 crossed the heliopause, the point where the outward pressure of the solar wind is no longer strong enough to hold back the material between the stars. And in that moment, without ceremony, without a visible marker, a human-made object entered interstellar space for the first time, not by leaping across a line, but by passing through layers. First, the termination shock, where the solar wind slows abruptly. Then, the heliosheath, where solar and interstellar particles mix in a turbulent region. And finally, into a domain where the sun is no longer the dominant influence. And what it found there did not simply confirm our expectations, because the measurements of magnetic fields, of plasma density, of particle behavior, revealed a space that was more structured, more complex, and in some ways more surprising than the models had predicted, which is exactly what you hope for in science. Not just answers, but better questions. And the reason this matters, the reason it still matters right now, is because every bit of data Voyager sends back is coming from a place no other spacecraft has ever reached. So when you think about Voyager 1 today, don't just think about a machine that is fading. Think about what it already accomplished before it began to fade, because it didn't just travel farther than anything else. It redefined what we expected to find along the way. And in doing so, it turned the edge of the solar system from an abstract boundary into something we could actually touch, measure, and begin to understand. August 2012 didn't arrive with a line drawn across space. No glowing boundary, no signal saying you are leaving the solar system now. And that's exactly what makes this moment so difficult to grasp, because what Voyager 1 encountered was not a place. It was a transition, a shift in conditions so subtle that you could pass through it without even realizing it had happened, unless you were paying very close attention to the physics. To understand why this mattered, you have to rethink what the solar system actually is, because it's not just the planets orbiting the sun. It's something much larger and far less visible. A vast bubble carved out by the solar wind, a continuous stream of charged particles flowing outward in every direction, pushing against the thin material that fills interstellar space. And as long as that outward pressure dominates, everything inside that region is, in a very real sense, still under the influence of the sun. For decades, Voyager 1 had been moving toward the edge of that invisible boundary, not in a straight, simple progression, but through regions where the behavior of space itself began to change. And the first major shift came when it crossed the termination shock, a place where the solar wind, which had been racing outward faster than the speed of sound in that medium, suddenly slowed down, compressed, and heated like a supersonic flow hitting resistance. And from that point onward, nothing behaved quite the same way as it had closer to Earth. Beyond that lies the heliosheath. And this is where things become messy in a way that only physics can be, because you are no longer dealing with a clean outward flow from the sun. You are dealing with an interaction, a mixing zone where solar particles and interstellar particles collide, deflect, and reshape each other's paths, where magnetic fields twist and fold in ways that are difficult to predict. And for years, Voyager moved through this region, sending back data that didn't always match expectations, forcing scientists to reconsider models that had seemed reliable when they were only theoretical. By the time Voyager approached the heliopause, the question was no longer whether it would cross into interstellar space, but how we would even recognize that it had, because without a visible boundary, the only way to detect the transition was through changes in the data. And what scientists were watching for was a combination of signals, a drop in solar particles, a rise in galactic cosmic rays, and a shift in the magnetic environment, indicators that Voyager was no longer dominated by the sun's influence, but by the broader galaxy beyond. And then, quietly, almost ambiguously, those changes appeared, not all at once, not in a single dramatic moment, but in a pattern that, when taken together, pointed to a conclusion that had never been reached before. Voyager 1 had crossed the heliopause, becoming the first human-made object to enter interstellar space, not by leaping across a boundary, but by drifting into a new regime where the rules were subtly but fundamentally different. What made this moment extraordinary was not just the milestone itself, but what came after, because once Voyager was in interstellar space, it began to measure conditions that had never been directly observed. And some of those measurements didn't behave the way scientists had predicted. The magnetic field, for example, did not rotate as dramatically as expected when crossing the boundary, suggesting a more complex interaction between the solar and interstellar fields, and the density of plasma inferred through subtle oscillations turned out to be higher than many models had assumed. This is the part that matters if you care about how science actually works, because Voyager didn't just confirm our understanding, it challenged it. It showed that even at the edge of our own solar system, the environment is more intricate, more structured, and less intuitive than simplified models suggest. And that kind of result is far more valuable than a clean confirmation. because it forces us to refine our theories, to ask better questions, and to admit that even after decades of study, we are still learning how our own cosmic neighborhood behaves. And all of this, every measurement, every unexpected detail, is coming from a spacecraft that was never designed to operate for this long. Now sending back data from a region no other probe has reached and won't reach again for decades. Which is why even now, as its power continues to fade, every remaining instrument matters. Because as long as Voyager 1 is still functioning, even in a reduced state, it is still giving us something we cannot get anywhere else. A direct, physical connection to the space between the stars. A place that until very recently existed only in theory and is now, because of this one aging machine, something we can finally begin to understand. Try stretching your sense of distance until it breaks. Because what comes next in Voyager 1's journey doesn't just challenge intuition. It completely abandons it. And the moment you attempt to translate these numbers into something familiar, they stop behaving like distances and start behaving like time, like history, like something closer to geology than motion, because out there where Voyager is headed, movement is measured not in kilometers, but in centuries and millennia right now. Voyager 1 is already about 165 times farther from the Sun than Earth is. A number that sounds impressive until you place it in context, because even at that distance, it has barely begun to leave the Sun's gravitational influence. And in late 2026, it will reach a milestone that feels almost poetic when you say it out loud. It will be one light day away from Earth, which means that a signal sent from us will take a full 24 hours to arrive, and another 24 hours for a reply to come back. So even the simplest exchange becomes a 2-day conversation conducted at the fastest speed the universe allows. And yet even that enormous separation is still, in a cosmic sense, close to home. To see how small that really is, you have to look at what lies ahead. Because beyond the familiar planets, beyond the Kuiper Belt, there exists a structure so vast that we have never observed it directly in its entirety, only inferred its presence through the behavior of comets. A spherical halo of icy remnants known as the Oort cloud, extending thousands to tens of thousands of astronomical units from the Sun, marking not a physical boundary you can see, but a gradual fading of the Sun's gravitational dominance into the broader galaxy. Voyager 1 is nowhere near it. Not yet. Not even close. And at its current speed, it will take hundreds of years just to reach the inner edge of that cloud. Hundreds of years during which human civilization will change in ways we cannot predict. And even then, that will only be the beginning, because the outer boundary of the Oort cloud may lie as far as 100,000 astronomical units away, a distance so vast that Voyager will need on the order of 30,000 years to pass through it completely. 30,000 years just to leave what we still consider our solar neighborhood. Let that sink in for a moment, because 30,000 years is not just a number. It is a measure of how different the scales are, because when Voyager finally exits that region, humanity, as we know it today, will be unrecognizable, if it exists at all. Languages will have changed. Continents will have shifted. Entire cultures will have risen and disappeared. And the entire span of recorded human history will still be shorter than the time Voyager spends simply drifting through this distant cloud of ice and debris. And even after all of that time, after tens of thousands of years of continuous motion, Voyager will still not be anywhere near another star. Because interstellar space is not crowded. It is not filled with destinations waiting just beyond the edge. It is overwhelmingly empty. And the nearest meaningful encounter lies tens of thousands of years further into the future. Meaning that what Voyager is really entering is not a region of exploration in the usual sense, but a vast, almost featureless expanse where the concept of arrival barely applies. This is the part of the journey that forces you to confront something uncomfortable, because we are used to thinking in terms of goals, of destinations, of progress that leads somewhere, but Voyager's future does not work that way. It is not heading toward a planet, it will orbit, or a system, it will study. It is moving through a scale of space where motion itself becomes the defining characteristic, where simply continuing forward is the only meaningful description of what is happening. And when you step back and look at it from that perspective, Voyager 1 stops being just a spacecraft and starts to feel more like a marker. A physical object tracing a line outward from the sun into a region so vast that even light takes years to cross it. A reminder that the space between stars is not just empty in the casual sense, but empty in a way that stretches time, distance, and expectation beyond anything we are naturally equipped to understand. And yet, despite all of that, despite the scale, despite the silence, it keeps going. Not faster, not smarter, just steadily, carrying with it the inertia of a decision made decades ago, moving into a future that is so long and so empty that the act of continuing becomes, in itself, the most extraordinary thing about it. At some point, and it won't feel like a dramatic turning point when it happens, the signal from Voyager 1 will simply stop. Not with a final message, not with a clear ending, but with silence. The kind of silence that doesn't announce itself, it just replaces what used to be there. And from that moment on, everything we associate with a mission disappears, because a mission implies communication, control, feedback. And without those things, what remains is not an active explorer, but an object continuing through space with no connection to the civilization that sent it. You might be tempted to think of that moment as the end, but in physical terms, nothing essential about Voyager's motion will change at all. Because the thing that has been carrying it forward this entire time is not its computers, not its instruments, not even its power systems. It is inertia, the simple fact that once something is set in motion in the near-perfect vacuum of space, there is almost nothing to slow it down. No air resistance, no friction, no gradual loss of speed. Just a steady, unchanging trajectory through the galaxy. And that means when the last transmitter goes quiet, Voyager does not stop. It doesn't even hesitate. It just keeps going inside the spacecraft. However, everything will be different, because without power, the systems that once defined its existence will shut down completely. The computers will stop processing. The instruments will stop measuring. The heaters that kept critical components within operating temperatures will fall silent. And the internal environment will begin to equalize with the surrounding space, dropping toward a temperature only a few degrees above absolute zero. A state so cold that almost all motion at the atomic level slows dramatically, leaving Voyager as a frozen relic, not destroyed, but inactive in every meaningful sense. From that point onward, time stops having the kind of relevance it has for us, because we measure time through change, through events, through sequences of cause and effect. But for Voyager, after the signal ends, there are no more events in that familiar sense. No operations being carried out, no data being collected, no responses being sent. Just motion, continuous and uninterrupted, stretching across spans of time so large that they no longer fit comfortably into human understanding. And yet, even in that silence, its path continues to intersect with the larger structure of the galaxy. Not in a purposeful way, not with intention, but as a consequence of the same gravitational landscape that governs everything else. Because over tens of thousands of years, Voyager will approach distant stars, not closely enough to become part of their systems, but near enough that their gravity will subtly alter its trajectory, nudging it, bending its path in ways that accumulate over immense stretches of time, turning what seems like a straight line into something more complex, more unpredictable the further into the future you try to follow it. One of those encounters will happen roughly 40,000 years from now, when Voyager passes within a few light years of a red dwarf star, not entering orbit, not interacting in any meaningful way, just passing by at a distance that, while enormous by human standards, is relatively close in galactic terms, and then continuing onward, because that is the defining feature of its future. Not arrival, not exploration, but passage. A sequence of near encounters separated by vast intervals of emptiness. And as you extend that timeline further, hundreds of thousands, millions, even billions of years, the certainty of its path begins to dissolve. Because the galaxy is not static. Stars move. Gravitational fields shift. Interstellar clouds drift. And over such immense durations, even small influences accumulate into significant changes, making it impossible to predict exactly where Voyager will be or what it will pass near, only that it will continue, carried forward by the same motion it has now. This is the part that is hardest to internalize, because we are used to thinking of objects in terms of purpose, of function, of roles they play within a system. But Voyager, after the signal ends, has none of that. It is no longer serving a mission, no longer contributing data, no longer part of an active process, and yet it still exists, still moving, still occupying space, a physical artifact of a decision made by a species that, by the time Voyager reaches even its first distant star, may be unrecognizable or gone entirely. So what you are left with is something that feels almost contradictory. A spacecraft without a mission. A message without a sender. An object that continues long after the system that gave it meaning has disappeared. And if you follow that idea far enough, you begin to see Voyager not as a tool, but as a trace, a line drawn outward into the galaxy that does not end when the signal does, but continues indefinitely, as silent, cold, and completely indifferent to whether anyone is still there to notice. Long after the signal is gone, long after every system on Voyager 1 has fallen silent and the spacecraft itself has become nothing more than a cold object drifting through interstellar space, one thing remains untouched by that loss of power, because attached to its side is something that was never meant to function in the usual sense, never meant to transmit, never meant to respond. And yet, in a way, it carries more meaning than all the instruments combined. A simple golden record, placed there deliberately, almost defiantly, as if we knew from the beginning that the mission would end. But the message did not have to. You have to understand how strange that decision really is, because everything else about Voyager was built with purpose, with measurement in mind, with the expectation that data would be collected, transmitted, analyzed, and eventually replaced by something better. But the Golden Record does not operate within that framework at all. It does not gather information. It does not adapt. It does not even guarantee that it will ever be seen. And yet it may outlast everything else on the spacecraft. Not because it is more advanced, but because it asks for nothing in return. Encoded into that record are 115 images, greetings in 55 languages, sounds of Earth that range from wind and rain to bird songs and heartbeats, and music that spans cultures and centuries. All of it assembled under the direction of Carl Sagan and his team, not as a scientific instrument, but as a statement, a way of saying that if something somewhere were ever to encounter this object, it would not just find a machine, it would find evidence of a civilization that once existed, that once looked outward and decided to introduce itself. And here is where the story becomes less about probability and more about intention, because the likelihood of that record ever being found is almost unimaginably small. Interstellar space is not just empty, it is vast in a way that makes encounters between objects incredibly rare. Voyager could drift for longer than the current age of the universe without ever coming close to anything capable of noticing it, which means the record may never be played, never be decoded, never even be seen. And yet it was still created, still placed there, still sent outward. So why do it? Why attach a message to a spacecraft that was never expected to reach another star within any meaningful time frame? Why include something that has no effect on the mission's success or failure? And the answer is that the record was never really about the future. It was about us, about the moment in which it was made, because it represents a choice, a decision by a species confined to a single planet to look at the vast, indifferent universe and respond not with fear, not with silence, but with something closer to curiosity and openness. What makes that remarkable is not the content of the record itself, although that is fascinating in its own right. It is the fact that we chose to send it at all, that in the midst of building a machine designed to explore the outer planets, we also decided to include a piece of ourselves, not in the form of technology or power, but in the form of culture, sound, language, and identity, as if to say that exploration is not just about discovering what is out there, but also about expressing who we are while we do it. And as Voyager continues its journey, long after its instruments have failed and its signal has disappeared, that record remains unchanged, unpowered, unaffected by the silence that surrounds it, carried forward by the same motion that drives the spacecraft itself, moving through a galaxy that may never acknowledge its presence, and yet still holding within it a snapshot of a world that once existed, a collection of moments and meanings preserved not because they were guaranteed to be received, but because they were worth sending. If you follow that idea to its conclusion, what you begin to see is that Voyager 1 is not just a machine that traveled farther than anything else we have built. It is also a kind of gesture, a physical expression of something deeply human, the desire to reach beyond immediate survival, beyond practical necessity, and leave behind a trace that says, in the simplest possible way, that we were here, that we have observed, that we created, and that at least once in the vast timeline of the universe, something looked up at the stars and chose to speak. And perhaps that is the most enduring part of this entire story. Not the distance, not the longevity, not even the science, but the fact that even as everything else fades, even as the signal goes quiet and the spacecraft becomes just another silent object among countless others, the intention behind that record does not disappear. It continues with Voyager, carried outward into a future where it may never be heard, but where it will never truly be lost either, because the act of sending it has already become part of what it means to be us.